Hello and welcome to this demo. In this session, we'll show you how to read messages in Avro format from MSK, Amazon's managed service for Apache Kafka, apply real-time transformations and aggregations, and then store the data as Parquet files in Amazon S3. In the data lineage view within Timeplus Enterprise, you can see the complete flow. We read from the MSK topic, apply SQL-based transformations, and then send the processed data to S3. We've set up a Kafka cluster in Amazon MSK. To inspect messages within the topic, we'll use the Red Panda console web UI. Since the data is encoded in Avro format, and we're not using a schema registry, Red Panda console can't decode the message content directly. Instead, we can view the content using Timeplus SQL. Here, you can see all the data structured in Avro format. Let's examine the Avro schema definition, which includes various primitive types and complex data structures, such as arrays of records. Next, let's look at the S3 bucket where the output data is stored. The organization IDs are used to create different folders as partitions. As you can see, multiple files have been created. If we download one and open it in VS Code, we can inspect the content of the Parquet file. Since the files are in an open format, you can also use other tools, such as Amazon Athena, to query them. For instance, I can create an external table in Athena that points to the S3 folder and loads all files. This allows me to query the table to view the content or check the total number of rows. Because we've set up a continuous data pipeline in Timeplus, each time the SQL query runs, the row count increases in real time. Now let's go over how this data pipeline is constructed. First, we define an Avro schema. We then create a random data stream for data generation. Next, we configure a Kafka external stream to read from the MSK topic using Scram authentication and the Avro schema we just defined. We set up a materialized view that reads the randomly generated data and sends it to the MSK topic. For the actual data pipeline, we create a Kafka external stream to read from the MSK topic, and we set up an S3 external stream specifying the bucket name, data path, and other settings. There are various settings available to control how files are generated in S3. For demo purposes, we set the S3 min upload file size to 2024, which represents 1 kilobytes. In production, you typically set this to a larger value to avoid creating too many small files, which can lead to high costs from S3 API calls. Timeplus also offers the option to create files during idle times in the data pipeline. In this example, we've set an idle timeout of 2 seconds, meaning that if no new data arrives from the MSK topic for 2 seconds, Timeplus will write the current data to a file and upload it to S3. Additionally, there are settings to support multi-part uploads for even greater flexibility. You may also notice the special partition by keywords. To enable other applications to read only necessary data, you can choose to use any SQL expression to create dynamic folder based on certain columns or SQL function. Then, use the partition ID in the write to setting. Then, using a materialized view, we continuously read data from MSK, apply transformations, and send it to S3. Let's run through this process in real time. I'll pause the materialized view and delete all existing files in S3. Once I resume the materialized view, you'll see new data files being generated in real time in the S3 bucket. That's it for this demo. Thank you for watching, and please feel free to share your feedback.